Secure your Elixir apps with Paraxial IO. From code analysis and bot defense to dependency checks, they've got you covered. Elixir first design with GitHub integration. Elevate your security at Paraxial.io. All right, what is up, guys? All right, today will be fun. We're continuing our Elixir Anti-Patterns guide, and we are going to be jumping into process-related anti-patterns. So this will be a good one. It's going to be a lot like the rest of these videos, less coding, more just walking through the guide and talking through the code examples they give us. But I think we'll learn a lot. It'll be a lot of fun. And yeah, let's go ahead and jump right in. I'm so happy that using Restream now, my chat window should always work. So that's cool. Let's test it out. Look at that. So exciting. All right, let's open up Safari. Oh, wrong window. And we're going to go to elixirlang.org and then click on guides. And we're going to the anti-patterns, process-related anti-patterns. And then we're going to be wrapping up this section, the anti-patterns section, tomorrow. I'm going to do another live stream tomorrow at 1:30. And we'll be doing meta programming. All right, let me make this bigger. Not too big. Oh, wait, let me close the sidebar here. There we go. All right, cool. Cool. I'm going to hide the chat window unless I become more popular. Oh, come on. My button's not working. Bummer. Let me just manually hide the chat window. All right, so process-related anti-patterns. This document outlines potential anti-patterns related to processes and process-based abstractions. I don't know why I have my headphones on. All right, so code organization by process. Problem: this anti-pattern refers to code that is unnecessarily organized by processes. A process itself does not represent an anti-pattern, but it should only be used to model runtime properties such as concurrency, access to shared resources, error isolation, etc. So when you use a process for code organization, it can create bottlenecks in the system. All right, so an example of this anti-pattern, as shown below, is a module that implements arithmetic operations like add and subtract by means of a gen server process. If the number of calls to this single process grows, this code organization can compromise the system performance, therefore becoming a bottleneck. All right, yeah, that makes sense, right? So let's see what's going on here. We have a module here called calculator, and it is a gen server. So we're initializing it, and we have some helper functions here. We have add and subtract, and then it's calling our handle call here, and we're passing in add and subtract. So we have our two functions here. And if you're not familiar with gen servers, you have state with gen servers. So it is like a continuous loop, right? And then everything that you do, you're always returning the state of that process. So in this case, we're passing in two parameters, A and B, and we're either adding and subtracting them, right? And then we're pattern matching to the proper gen server call. So we have add here, and man, come on, mouse. So we have add here, we have a tuple. So you pass in a tuple, and we're pattern matching to the atom add, and then our values are the following. Why is my brain not working? Are the following arguments passed in. That's the word I'm looking for. And then we have so when you do a handle call, you always get a reply back. And so we're returning the value, and then the state of our overall process. Okay. So obviously it doesn't really make much sense. Hey, Lewis, what's going on? It doesn't make much sense to use a gen server for simple arithmetic, right? And so the anti-pattern that they're saying here is if you start calling this process from a bunch of different resources, you have a single process here and it could bottleneck simple arithmetic, right? So let's see here. They're starting, and then in an IX shell, they're just starting up our gen server. And then they're just doing calculator.add, and they're passing the two values, and they're passing in the PID, which is the process ID, and then subtract. So like obviously this is going to work great in this situation, but at scale, it could be a bottleneck. And I feel like this is a major problem. Like gen servers are so exciting, and when you first start learning how they work, you want to use them for everything, but it doesn't actually make sense to use them for everything, especially like this. So let's see what refactoring this would look like. In Elixir, as shown next, code organization must be done only through modules and functions. Whenever possible, a library should not impose specific behavior, such as parallelization on its users. It is better to delegate this behavioral decision to the developers of clients, thus increasing the potential for code reuse of a library. So yeah, right here, we just have a module called calculator and simple functions where we're just passing in the values we want to add, and we're returning them added together or subtracted. And then as you can see in the IX shell, we get the same responses, and you're not using a single process for all of your clients using your app, right? So that makes sense. Don't use gen servers all willy-nilly, guys. All right, scattered process interfaces. The problem in Elixir, the use of an agent, a gen server, or any other process abstraction is not an anti-pattern in itself. However, when the responsibility for direct interaction with a process is spread throughout the entire system, it can become problematic. This bad practice can increase the difficulty of code maintenance and make the code more prone to bugs. All right, so let's see, scattered process interfaces. Oh, this is a good one. All right, example. So the process or the following code seeks to illustrate this anti-pattern. The responsibility for interacting directly with the agent is spread across 4 different modules. Okay, so an agent is just a simplified gen server. It's a process. If you don't know what that is, yeah, it's a good way to hold state, like if you need a counter or other simple things like that. So what we're doing here is we have a module A, a module B, module C, and D. And what looks like what's happening here is we're accessing our agent process from each module directly. So we're calling agent.update here, and it looks like we're passing in an anonymous function here and returning the value 1, 2, 3. And then here we're taking content and we're returning the content passed in from whatever process is being passed in, right? And we're returning a map with a key value. And then C is returning something completely different. So we're using this process differently from 4 different modules. We have a list here, and we're putting an atom value. We're prefixing an atom value to the front of a list here. And then let's see, down in module D, we are we're updating, and then we're fetching from our process content. So we're doing all different things here. And let's see, this spreading of responsibility can generate duplicated code and make code maintenance more difficult. Also, due to the lack of control over the format of the shared data, complex composed data can be shared. This freedom to use any format of data is dangerous and can induce developers to introduce bugs. Yeah, so if you're passing in, different formatted data in all these different modules, it's basically like a shared state, right? And you're not controlling what kind of data is being put in your state, which could be incredibly buggy. All right, and then, so let's see. Now they're showing us how this works through examples. We're just starting the agent, and we're getting the PID here, and we're calling a.update, and we're passing in the PID, update, all these things, right? And then we're getting, when we fetch the process, or the content, I should say, with D, so d.get, we're getting the atom value and our weird map with value 1, 2, 3 in it. And let's see, if we go back up, so as you can see, like all these modules added different things into our state. And so here we put the value of 1, 2, 3 in, and that gave us content. And then we put it in a map, and then we prefixed an atom to it. And so we're ending up with a mess, and we're not actually sure what's going on, probably. So for a gen server and other behaviors, this anti-pattern will manifest when scattering calls to genserver.call arity3 and genserver.cast arity2 throughout multiple modules, instead of encapsulating all the interaction with the gen server in a single place. So refactoring. Instead of spreading direct access to a process abstraction such as agent over many places in the code, it is better to refactor this code by centralizing the responsibility for interacting with a process in a single module. Yeah, that makes a lot of sense. So you're always going to want to, like, whether it's a gen server, an agent, whatever process you're making, you're going to want to just create helper functions. And those helper functions are the only ones that directly interact with your process. And then when you want to use it from other modules, you're always calling those helper functions. And then you can control what kind of data is being sent in, and you're not manipulating a state in different ways all across your code base, because that would be incredibly hard to debug as your code base grows and as more developers touch your code base. So this refactoring improves maintainability by removing duplicated code. Also, oh yeah, I didn't even think about that. Your helper functions, from each module, you're now updating and fetching directly from your process in all these different places. So you're creating a lot of duplicated calls, right? So it also allows you to limit the accepted format for shared data. Yep, that's what we said, reducing bug proneness. So as shown below, the module foo.bucket is centralizing the responsibility for interacting with the agent. Any other place in the code that needs to access shared data must now delegate this action to foo.bucket. Also, foo.bucket now only allows data to be shared in map format. So that's very important. All right, so we have our module foo.bucket. It's an agent. We have our start link to start the process. But now, as you can see here, we have a get function and a put function. All right, so we pass in our bucket with our key for getting it, and then we directly access our agent from this function instead of from other modules. So we fetch the key we're looking for, and then our put function will update our bucket by putting this value and key into it. So now it is centralized and only happening in one spot. And now from our IEX shell, we can start our agent up just like before, but we go through foo.bucket. So we can say, okay, put key value milk in, value of 3, put key value beer in, value of 7. And then to access it, we can say get now, and we can just pass in our key beer and we get 7 back. And we can get milk and we get 3 back. So it's much cleaner, and you would use these functions in each module. So like if we went back up to each of these modules, instead of having the like update agent update, we would call foo.bucket.put, right? And we wouldn't directly access our process except for our agent module here. Yeah, that makes sense. Yes, Lewis, processes, this would be OTP. So agents are processes, Gen servers are processes. This is the fun concurrency piece of Elixir. And I have a really good OTP Gen server process section in my course on Indie Courses. If you're interested, that is there. I'll probably eventually do some Gen server stuff on my YouTube channel. I just haven't had time. But if you want to buy my course, it's a great resource. But yes, this is OTP. So additional remarks. This anti-pattern was formerly known as agent obsession. Let's go check out that. Oh yeah, code smells. This is good stuff. I know we've mentioned this before. Adolfo has also brought this to my attention, and I'm trying to remember. Lucas, that's correct. So Lucas is the creator of most of these, all the code smells, the anti-pattern section, which is really cool. So check out Lucas, follow him on X if you don't, or any social media, but he's doing really good stuff. Super smart guy. All right. Sending unnecessary data. Problem. Sending a message to a process can be an expensive operation if the message is big enough. That's because that message will be fully copied to the receiving process, which may be CPU and memory intensive. This is due to Erlang's shared nothing architecture, where each process has its own memory, which simplifies and speeds up garbage collection. So this is more obvious when using send arity2, genserver.call arity3, or the initial data in genserver.start link. Notably, this also happens when using spawn, task.async, task.async stream, and so on. It's more subtle here, as the anonymous function passed to these functions captures the variables it references, and all captured variables will be copied over. By doing this, you can accidentally send way more data to a process than you actually need. That's actually good to know. I don't think I realized that. All right, so example. Imagine if you were to implement some simple reporting of IP addresses that made requests against your application. You want to do this asynchronously and not block processing. So you decide to use spawn arity1. It may seem like a good idea to hand over the whole connection because we might need more data later. However, passing the connection results and copying a lot of unnecessary data like the request body, params, etc. However, passing the connection results and copying a lot. Yeah, so if you pass in, let's see, inside of this spawn request, so we're spawning a process and we're calling a function called log request IP. And it looks like all we want to do here is just log the IP, but they're sending in the whole connection struct or the connection map. I think it's a struct, whatever it is. But we're passing in everything. So that's request body param. So a lot of unnecessary data. And so this problem also occurs when accessing only the relevant parts. So this is what I think was interesting. I didn't know this. So when you call spawn, and then inside we have our anonymous function, we're calling log request IP, and we're saying con.remote IP. You would just assume you're passing in the IP here. But this will still copy all of the con because the con variable is being captured inside the spawn function. The function then extracts the remote IP field, but only after the whole connection has been copied over. This is important to know. This is good. I never knew this. So I'm assuming we just have to, declare a variable, pass in the variable, because I never realized that con would be completely copied just being inside of a spawn. So good to know. See guys, this is why reading docs is so much fun. You learn stuff. You learn cool stuff. All right, so send arity2 and gen server APIs also rely on message passing. In the example below, the con is once again copied to the underlying gen server. All right, so using gen server in the same manner, we're calling our handle call here for report IP, and we're passing in the whole construct instead of just the IP address. It is a struct. See, I remember some things. Refactoring. This anti-pattern has many potential remedies. Limit the data you send to the absolute necessary minimum instead of sending an entire struct. For example, don't send the entire construct if all you need is a couple of fields. That makes sense. I mean, that's how you want to handle almost anything that you're doing, right? You don't want to pass in unnecessary data for even a simple function. You only want to pass in things you need. So if the only process that needs data is the one you are sending to, consider making the process fetch that data instead of passing it. That makes sense. So if the process needs it, maybe make the process fetch the data versus passing it into the process. Some abstractions, such as persistent term, allows you to share data between processes as long as such data changes infrequently. In our case, limiting the input data is a reasonable strategy. If all we need right now is the IP address, then let's only work with that and make sure we only are passing in the IP address into the closure like so. Yeah, so create a variable, grab that IP address, and then just pass in the IP address inside of spawn. That makes sense. And then, or in Gen Server's case, it looks like we're allowed to use the dot notation and grab the remote IP, because up above, they were passing in the whole con again. All right, oh, where did I go? Okay, moving on, cool. So that's good to know. I never knew that about spawn. So unsupervised processes. Ooh, this is a good one. Problem. In Elixir, creating a process outside of a supervision tree is not an anti-pattern in itself. However, when you spawn many long-running processes outside of a supervision tree, this can make visibility and monitoring of these processes difficult, preventing developers from fully controlling their applications. A good thing to note, too, if you're spawning processes outside of supervision trees, and that process, the process that spawned it crashes, you could just have floating processes out there that you don't have access to because you will no longer have the PID to control them and all of that. So there are good things to keep in mind there. And then when you use supervision trees, if they crash, the processes are normally restarted, or depending on whatever you set, it could just kill itself and not respawn. But you have more control of it through your supervision tree, which would be your, by default in like a Phoenix project, it would be in your application.exs file. No, I'm not actually sure. I want to make sure. Yeah, it would be in your application.ex file. So that makes sense because it needs a supervisor to be able to restart. Well, not only to be able to restart, to keep track of its state, right? So if you create it in the supervisor, your process has a name and you have access to it. And if your supervisor crashes, all the processes that supervisor has crashes, and then it would work off your reboot strategy, right? So either they would all be restarted or they would all be killed, but at least you don't have any hanging processes you don't have access to, if that makes sense. Why isn't... There's my chat window. Now it's working. But it's not turning off. I think I know why. Sorry guys, ADD. Gotta fix this. Chat. Just chatting. Wait a sec. It should work. Oh well, I'll fix it later. At least it turns on for me. No problem, Lewis. All right. Let's see. Unsupervised process. Okay, we were already talking about this. Let's see. I let myself get distracted by silly things. Okay. So the following code example seeks to illustrate a library responsible for maintaining a numerical counter through a gen server process outside a supervision tree. Multiple counters can be created simultaneously by a client, one process for each counter, making these unsupervised processes difficult to manage. This can cause problems with the initialization, restart, and shutdown of a system. Yeah, okay. So let's see here. We have a counter here. It is a gen server. So global counter implemented through a gen server process, which is fine, right? We have our start link. We have an initial value. Okay, good stuff. And then we have our helper functions of getting it. So you pass in a PID name, or by default, it is the module. So it'd be our counter module, which makes sense. And then bump, let's see, bumps the value of a given counter. So by default, it is just our counter module, or we can pass a PID name and then the value and we bump it, right? And then our init is just the counter, which is going to be 0 unless we pass in options of an initial value, which I guess we're setting as 0. So it looks like it'll be 0. All right. And then we have our handle calls, so get and bump. And we're just accessing these with our helper functions, which is good, right? And then in our IEX shell, we are starting up our gen server here, so counter.startLink. And then we can say counter.get, and it gets the initial state of 0. And then, okay, so here they're creating a second counter and they're setting the initial value. So up here, we didn't pass in any options. Here they're passing in the options 15 and the name. So they're naming it other counter, which is an atom. And so now you see that we have a process of .115 and a process of .120. So now when you say counter.get, you can pass in the name and you get the initial value 15. And then we can bump it by -3, you get 12 back. And then if we just say counter and pass in counter, because that's the module name, right? With 7, then we get 7 back because it's 7 and 0. So we have 2 counters. We have 2 separate gen server processes going. But like this could get difficult to keep track of. And like I said, any module or process that created this, if it crashes, then you just have your floating counter gen servers out there. All right, so refactoring. To ensure that clients of a library have full control over their systems, regardless of the number of processes used and the lifetime of each one, all processes must be started inside a supervision tree. As shown below, this code uses a supervisor as a supervision tree. When this Elixir application is started, 2 different counters, counter and other counter, are also started as child processes of the supervisor named app.supervisor. One is initialized with 0 and the other with 15. By means of this supervision tree, it is possible to manage the life cycle of all child processes, stopping or restarting each one, improving the visibility of the entire app. All right, so we have our application .ex file here, and you add your gen servers to the child list here. And in this case, so by default, we're calling start link. That you're just following a behavior of gen server. So we can just say counter, and this will be all the default values, and start a counter named after the module itself, which is counter, with the initial value 0. And then we have our supervisor.child spec, and we're passing in the counter with the options name, which is other counter, and then initial value of 15. And then we're also giving it an ID other counter. And then we're starting all of our children with the strategy 1 for 1. And if I recall, 1 for 1 means if the process crashes, that process will restart itself. You can do like, don't quiz me off the top of my head. I don't remember what they're all called, but you can like one for all, like if one crashes, they all will be restarted. And there's a whole bunch of different strategies you can set. And so you want to use supervisors, and you can also dynamically create gen servers in a supervisor. So like, trying to think here. Let's say you have like some multi-tenant application and you have some scheduling gen server, right, that you want to hit an endpoint every hour or something, and you're doing gen servers to do it, but each organization has to have its own gen server. You could dynamically create a gen server for each organization, right? And so you can dynamically do them, and it's very simple. You just add a couple, you do a dynamic supervisor, and I also go over that in my course. So you guys should check that out. All right, so now when we start our process, so we're starting our IX shell, and our processes are automatically going to start when we start our Phoenix project now. So we're doing supervisor.count children, and we get back, we have 2 active children, and they're workers. All right, so then we can do counter.get, pass in the counter module name, we get 0, and then we can do .get other. There we go. It works the same way. We can bump 7, and then here you go. So now through the supervisor, you can terminate a child, pass in the counter, and it basically, all your processes are named and you have access to them through your supervisor. And then when we count our children, now we only have 1 active. We still have 2 workers. And then when we try to access the process we killed, it says no process, the process is not alive. So, and then supervisor.restart, now we can restart that counter and it works. So supervisors give you a lot more control, and you won't have dangling processes in your application. Well, that was fun, guys. All right, so that was our process-related anti-patterns. Yeah, this was fun. I learned something about the spawn and passing in variables or structs, so that was cool. And let's see, tomorrow we are wrapping this up with I think it's metaprogramming anti-patterns. So that will be fun. All right, guys, thanks for tuning in, and I'll see you guys tomorrow. Enjoying the video? Show some love with a like and hit subscribe to stay updated. To support me and keep the content free, click join for memberships or pick up a course at elixirmentor.com and get free access to my private community. Let's jump back in.